Hi, class. I want to do a short video about the project. And we have 8 projects over the course of the semester, and they're really an important part. They're kind of like the culmination of the learning for each unit, and then we apply what we've learned in some way, some creative way that we can maybe extend onto the things that we've talked about. And so I want to open up here project one. And again, I've been making changes every semester. I make little changes, and this sheet I'm working on making a few minor changes, but for now, it'll be almost exactly the same. So let's see if we can get that up there. So the project again is if we read this, you create some type of artwork, and uh, it's not as flexible as it used to be. With having this course online, it was always on ground, and sometimes students would bring in pieces that they would put together. They could be sculpture or some type of hand drawing, oil painting, some construction or something. And of course, we can't do that now with this being online. And so basically, it's going to have to be some type of digital file that you submit to the Canvas grading area. So you'll take the project file, which is on Canvas there, as I just opened up, and the idea is that the project can be an extension of a classroom assignment or concept. It cannot be a repeat of the classroom assignment. So it must be grounded in math course. The course is about using math to create the art or design, and then be a real life application. So, and it says see below here. And so um, the application must be identified by an average consumer and not abstract. So it's important. It's one of the more common things that gets miscommunicated or misunderstood in this creative geometry class, that people don't understand clearly, that it has to contain mathematics and the math that we talked about in that unit. Be real life application, be identifiable and not abstract. Okay, so, and then you'll submit that to Canvas. So for example, here's an example: hypercube table. And in unit one, um, a lot of times I just tell students, well, if you get stuck, the hypercube is very mathematical. It's easy to apply to something real. So you can always kind of fall back on that. And maybe I shouldn't say that because it seems like a lot of students will end up doing that just to get the course going. But I want you to be creative in what you. I'm not saying that this isn't creative, but maybe could be more. I think with such all the opportunities we have with what we learned about the fourth dimension or higher dimension in activity one. And so I'll pull that activity one up in just a second, but let me just talk about this. So again, I think that this is very obvious for the first project. Clearly, this is a mathematical fourth dimensional object, right? This is a hypercube. So it's a type of tesseract. And then they simply took and put a tabletop and set it on top of this hypercube looking steel, or some type of frame that they built a table base out of. and they put tabletop on and have some books or something sitting here on top of the table. So this would satisfy all of the requirements. Again, it is a not simply a repeat of a classroom assignment, and we didn't do anything like this for our classroom assignment. We looked at some different things, but this again is the mathematics of it, right? The hypercube. So a very basic idea. And it's identifiable as a table. So that's my real life application. And I think everybody can see it's a table and so on. So yeah, that's pretty obvious. And then you would go through and there's a few questions about what you had done. So basically you would go in and say, what's the title? And you could say, okay, hypercube table's the title. What is the real life application? Of course, it's a table, so that's pretty obvious. Again, this application is very, very straightforward, right? And simple idea. What dimension is your artwork? Well, we would say it's a 4-dimensional table, right? Because again, the base of the table is a hypercube. And what mathematical concept did you use from activity 1? Again, we used the mathematical concept of a 4th-dimensional object because this thing contains 16 vertices, and we know through that math induction that that's what a 4th-dimensional object would have. And where does it appear in your artwork? Well, that's pretty obvious. Again, it's the base of the table. And how was math used to create the artwork? It was simply, we just used a hypercube, basic 4th-dimensional tesseract. And what materials did you use? So, if you used Illustrator or Photoshop or something, you would just put that in there. So, and those would be the questions that you would fill out in there. So remember that when you think about your project, so I'm going to put this down for now and pull up the project activity 1. Just want to back up to activity 1 for a minute. And when you're thinking about your project, you want to go through the activity, which you should have already, answered all the stuff first before you do your project. And if you look at the video I made, I kind of like walked through all this stuff. And we'll talk very briefly about it when we have our meetings for the class online. But now, this beginning of this activity, we talked about a spiritual approach. So that's not acceptable for project 1. That's a spiritual idea, not a mathematical idea. Okay, so we're going to say that's not going to help us except the one thing that we said is Schumacher talked about these levels that were involved in dimensions. So we need to try to think about that, of something being creative out of these, these levels underneath. And assignment 1, so we had to come up with some kind of idea of higher, and I'm not sure what you came up with for higher levels. That may be something that you can build on and create a visual for it. And so I talked about a book, with letters being one level and words the next level, and sentences and paragraphs and things. So you could build into the idea of a book being a higher dimensional real world concept. Again, because it all falls in that hierarchical structure. One level contains what's underneath it. And it's very much so what, mathematical approach would be. It's a very inductive idea, even though it sounds like it's an English kind of idea, but it's also very mathematical. Um, and then we moved down to some of this other art movements like the Cubists. And then we talked about how seeing something, getting away from perspective and seeing something, from a two-dimensional and looking at things from different viewpoints. And you may say, well, you know what? I like that idea. I can come up with something. And so you may want to follow that cubist thing. Now, you want to go beyond and try to go a little more in depth about than what we did, right? We know what Picasso did, uh, and we would maybe kind of expand on that in some way. And we talked about using geometric shapes, and you could think of something of how that might build into something that would be considered fourth dimensional. Uh, and again, so we go to the Picasso-like picture we looked at. We don't want to repeat. So your project can't be just a repeat of, like, say, what we did here in the assignment, where you took a picture from different angles and pieced it out and put it together, and then that was it, right? We need something more added to that. And I'm really trying to push being creative. So it's nothing. There's no real right or wrong as long as you follow, the basic directions. And Duchamp talked about motion, right? And so his idea of creating an image based on moving a three-dimensional image through space, and then that area, so you could think of, uh, how can that tie into something that you do? Maybe in, the bouncing ball animation, when you talk about motion, things like that, walking or so on, and what does that create? Different types of walks, and that idea may be interesting to you. And there were lots of other examples of creating then the three physical dimensions with a fourth non-spatial dimension, but was created from that, like positioning three-dimensional objects a certain way to create this cooperation. And so that could be something. We said color, Santelli talked about um, negative spaces and so on. So we want to think about these ideas, right? The geometry approach, right? We know what Duchamp said about that. We looked at the pictures here. We looked at those 1, 2, 3, and 4 in like motion, and not the same as Duchamp looked at like motion, but actually just 3D objects moving around, creating a fourth dimensional, a movie, in a sense. Um, Riemann talked about the math approach, and we talked about how Perelman solved a very important fourth dimensional theorem. So mathematically, we can show that, yes, from a math standpoint, there really are higher dimensions. And we're just trying to look at these examples. Hypercube, points in four space for quaternions, and then there was a bunch of examples I looked here that you can get. So then also remember that there were some examples. So let's look at an example here of project, and I'll put the video right underneath here. Let's look at this hypercandle and see what did this person had done for their project. Okay. And is it opening? Let's see, I'm trying to find it. Is it this one? Yeah, that's it. Okay. should have been. Let's just get rid of that. All right. Oh, it's. Okay, I have too many things open, and all right, there we go. All right, so again, the file is on Canvas. So you download the file, and then you kind of fill in. So this person did a hyper candle, and again, this was like a hyper table. So a little bit of a stretch, not much. And would it be considered real world? Yes, we kind of understand the idea of a candle. Um, and does it relate to your program? So this person was an illustration major, could be used for rental promotion advertisement. And you don't have to do things in your major. So your project doesn't have to be in your major. You don't have to, if you're a computer animator, you don't have to um, do an animation. You can just work on characters or things like that. Lots of different things you can do. So, so this person, they did a hypercube to help them mold this candle, the shape of the candle, and they did it in Photoshop and Illustrator. So we're going to get on here and look at, here's the candle, right? So pretty obvious, and that's what I mean by, we kind of recognize pretty easily what it is and what it's going to be used for. And they put this on the table. So again, this is very basic, nothing wrong with it. It's exactly what I'm looking for. The mathematics is there, and that helps create this shape, very doable shape. So this is something that could be created. I think it's actually a pretty nice looking candle. I like it a lot. Candle holder, okay. You can put the little tea candles in there and keep people from touching it or getting near the flame. So, and it could be nice in a certain type of setting. So that worked out good. And let me get that. Now let me. I'm going to pull another one over here because I don't want to show everything that's a hypercube. Here's another example. And again, this is hyper fashion, hypercube pattern. So they decided they were going to create a pattern out of the hypercube. Now let's say that we didn't have this dress here. This was all, this was not there, okay? And they just had these, and they turned this in and said, yes, there's my hypercube pattern. And then this would not be acceptable. Again, assuming this dress wasn't here. So you create a pattern, and again, remember, it cannot be abstract. It has to be easily identifiable, real life type of object. So the math is obvious. Here's hypercube, and there's some nice patterns in there, and they could easily be used in lots of different ways. You can pick whatever way you want to apply that pattern, and this person put it on a dress. So I think it's recognizable. Okay, here's a dress that's got this hypercube type of patterns that were created on it. So again, it could be printed on objects, phone case, dress shirts, and they gave it one example. And they talked about defining the dimension of movement. In Picasso's sense, where one could see an object from all different perspectives from a higher dimension, I think this artwork is defined by that too. The longer you look at the image, the more you can see different types of rectangular prisms from different angles. So that's a great creative idea. They took Picasso's sense and put that to work. And then it's almost like illusional in a sense, where your mind kind of sees it one way and then the other. And we'll talk about, perception and how it can be fooled. And so that's kind of a great idea. Is it inside or outside in image? And so this is a step more, a higher level of creativity with what this person learned about the fourth dimension. So you want to challenge yourself, and that's the goal, right? In the course, uh, again, I know a lot of times you can say, I just, want to get it completed, and that's okay. But I think that anytime you have an opportunity to learn and you don't take advantage of it, you're really cheating yourself. You want to become the best illustrator or designer or game designer or a business person or whatever you're doing here at Ringling or want to get into. You only, get better by working at it and not just doing the same old things you've been doing. So we want to try to do things that you haven't been doing and working with, and that'll expand your creative self. So, so again, this is one that is works very well, and it's not a hypercube, uh, even though that was used for the pattern. We don't. That's not so apparent like the other ones. And again, I'm going to look down. Now, here's one, and again, it's kind of like a hypercube, but it's more than that. So if you go through and you look at, this is a hand soap container, so pretty neat idea. So you have the dispenser inside, and the outside you can fill up to. They talk about it here, this idea, and this is a very doable. This could be a very realistic type of product. And a lot of people throughout the courses I really like with this creative geometry. They create a lot of things that could actually be used and would probably sell very well in the real world. And that's why I like, and I had students that would, get back to me and communicate with me after the course and show me how they use the ideas that they learned in my class as a product, a real product that was selling in the real world. So that's why I like these being real world applications because, there's a good chance that something you do, you may end up using. Okay. And I think that's like the greatest accomplishment, that you can get out of, something like this. And so if you go down through and you'll see again that they wanted this to be more than just a typical container. Uh, they wanted it to be a little bit different. And so that's kind of a neat kind of concept, a little bit more than just putting a hypercube and a spout on top maybe and squirting out. So it's a good idea there. And we have other examples here. So you'll note you got a chance to look at these. So again, these are other projects that people had turned in. Really neat ideas. Why these are all hypercubes, and I will change some of these as we go. But last semester when we got started, and I wanted everybody to kind of do a hypercube type of idea, and I just tried it. I didn't like it as much as previously, so I'm trying to get away from that now. So I'm going to change some of these, but there, uh, some neat ideas. You can look at that, go back through the activity, and see what you can come up with. And of course, you can always ask questions. Email me or when we meet, ask questions about those projects. So, but and again, if you have any issues on submitting, I can put a file up here on how to submit to Canvas. But I think you guys are probably all pretty good at least submitting, or will be able to. submit to the Canvas grading area. And I've got to go back and make sure they're all open so everybody can submit, and get that done here in the next few days. And I'm going to go ahead and end the video and talk to you in class.